We often see some of the insects walking on the surface of water. How can they do that? Why are water drops always spherical? How can the camphor move? Some of the plants suck water. How can they do that? How can water drops adhere to the faucet against gravity? And by the way, Marangoni effect? Let's have a look. In order to understand this effect, let's do a small experiment. And all you need is bowl, a drinking water, chili powder or any other lightweight powder and cotton buds. Sprinkle chili powder or any insoluble powder uniformly on the surface of water. Dip your earbud in the soap solution or something very similar to it. Now dip this earbud on the surface of water. Wow! Can you see that? All the powder particles on the surface of water were pulled outside toward the edges of the bowl. The answer to all the above questions are surface tension. All the above effects depicts that the properties of a surface are quite often marked differently from the properties of the bulk matter. By surface, I mean approximately 10 to 15 molecular diameters. A molecule well inside a body is surrounded by similar particles from all sides and experiences forces from the water molecules from all sides. But a molecule at the surface interacts with air molecules from the above and water molecules from the below. This asymmetric force distribution is responsible for creating a tighter bonds on the surface and makes surface like a stretched elastic membrane, which is responsible for surface tension. In case of insects, an upward surface force acts on each leg, balancing the weight of the insect. Whereas in case of water drop, because of the existence of forces across any line on the surface, the surface tends to shrink whenever it gets a chance. So a small drop of liquid takes nearly a spherical shape. This is because for a given volume, the sphere has the smallest surface area. And of course, because of gravity, there is some deviation from the spherical shape, but for a small drop, this may be neglected. Finally, plants. When you take a straw and dip it in liquid, some liquid travels up, which is called capillary action. When you decrease straw diameter, height of the water column increases. That implies smaller the diameter, longer the water column. Plants use similar straws, but its diameters are in the range of nanometers, which helps them to suck water so high. If you have any doubts, don't forget that you're not alone. And thanks for watching and subscribe to learn science like never before.